Hello, Cynthia.
Hi.
Welcome. You're my first student here.
I was actually showing my mom how it works.
Oh, okay.
Yeah. I'm like,
That's
oops,
cool.
I forgot to turn the video off.
Okay, so we'll get started in just a minute. Do you want to see yourself on video?
No.
Okay.
I already took it off. Bye.
Okay. So do you have your workbook? Hi, Drelyn. Welcome. We'll get started in just a minute. All right. Just about time to get started. How are you? Drelyn, you're the only one here, so you can talk if you want, but if you don't want to, that's fine too. We'll just go ahead and move on. But today's lecture is on superior. I guess I'll put it back down here. Superior and inferior planets, right? Superior and inferior planets. What makes one superior or one inferior? And that is a question that you will need to know, right? So we're going to talk about that. Hello, hello, hello. How you guys doing? Welcome. We're just getting started. How you doing? Hello, hello. Welcome, everybody. How you guys doing? Hi. Hey, I see people. I see you. Well, I guess actually I got to switch my camera back here. I see people. Hey, hello. Nice to see you guys. So we are going to talk about planets today, and actually how we see the planets in the sky. They're called superior and inferior planets. And, you know, it's actually not that big a deal. It's kind of a fun thing. But we're going to talk about how we see the planets. We'll do a little worksheet in your book. So you should have your workbook with you. And you want to take some notes because there is a quiz you have to take afterwards. It's already posted. So, but you might want to wait until you finish watching the video. Oh, yeah, let's fix my color here. Okay. All right. So actually, I want to start off today with a special vocabulary word. It's kind of a fun word. And you may or may not know it, but after today, you'll know it, right? Here is the word. The word is syzygy. Syzygy. Does anybody know what syzygy means? S-Y-Z-Y-G-Y. Isn't that a fun word? Syzygy, right? Anybody? Anyone want to chime in? Okay, so it is a planet. It is an alignment of celestial objects. So for example, when you have an eclipse, right? A syzygy is whenever you have a conjunction or an alignment of celestial object. For example, a solar eclipse is the sun right here, sun, and the earth is over here. And what happens is the moon gets right in the way. What's the symbol for the moon? There it is, okay? And so there's this perfect alignment of the three objects. That's known as a syzygy, okay? And other than astronomy, I don't know when you're going to use that, but it's kind of a cool term anyways. You can impress all your friends. And I encourage you, I challenge you to use the word syzygy as many times as possible this week, okay? Right? Okay, so every class, just drop it, you know. It's an astronomy term I learned this week, you know, syzygy. Everybody knows that, right? Anyways, okay, so we are going to talk about the planets, inferior and superior planets. Before we do, let's practice our stars and constellations and objects, and hopefully you've been practicing too. I do want to point out something important. You had a homework assignment that was technically due today, but I actually changed the due date because it's been kind of hard to see the stars. So if you turned it in, great. But if you did not turn it in yet, you actually have one more week to get it done. So let me just show you that on Canvas, right? So we're gonna share screen, go to Canvas and take a look right here. So the star magnitude homework is due now. You have one more week, okay? And then you also have one more week to do the indoor telescope quiz. So if you haven't done it again, that's not a problem. Just do it before next week. April, whoa, I gave you even more time for April 9th for last week. What? No, that's coming up. Never mind. You have a few days. You have until Friday to do the quiz for this class. That's right. And I did give you extra time, but not that much. It's done. And then if you want extra credit, don't forget mythology extra story extra credit. You go in here and then write in your own words a story about a constellation, anything that we've covered in the class. This could be from the winter to the spring, right? So actually, if you just look up mythology stories, there's some really great mythology stories. You can find all kinds of them. Mythology story here, Greeks myths, Greeks gods and goddesses, right? And you could go and look up a constellation. Oh, Orion, that's funny. That is spelled differently. Actually, I don't know if I'd stay here. That's pretty fun, unless that's the original spelling, which I just don't even know. That would be really funny. Is Orion an alternate spelling? Doesn't say that, huh? I don't know if I'd go to this page if they can't spell the word Orion, unless it's another spelling of it. Is it enough alternative spelling? Oh, it is another spelling. Ah. Oh, no, sorry. Not to be confused with Orion. They got confused. I wouldn't go to the other one. So anyways, yeah, it looks like Wikipedia even has some mythology on it. So you can do your extra credit and you get 5 points extra credit. Hello, okay, if you go and then you have to include your link that you used to do your research so that I can go compare, okay? So I want to see your original work and really whatever you do is good. So you don't have to worry about being perfect or amazing. Just tell a story and tell it in your own words. Okay, that's the mythology extra credit. So now let's practice our stars and constellations. Okay, so I have up again Stellarium, which I highly recommend. Stellarium. I just realized something. You guys can't see if I do this. And if I do this, can you see the Stellarium right now? Somebody help me out. Can you let me know if you see it? Look at it, just say something in the chat or something. Thank you.
Yes.
You can see it. Great. Thank you. Perfect. Okay, so there is a little, it's a little bit of a glitch. So I'm showing you Venus right here. You can see Venus. So don't forget Venus is in our sky right now. And near Venus, right, you guys had to do this actually, is what's this star or object? What is this cluster called? Actually, if you guys can turn on your microphones for now, that'd be cool. If you don't have one, that's fine. Otherwise, I'll just wait a moment and then I'll say it out loud. But the idea is to, I can hear you.
Oh, nice. Okay.
So what is the name of this star or object that I'm pointing at? Little cluster below Venus.
It's on the tip of my tongue.
Pleiades.
Okay, start the Pleiades.
Pleiades, yeah, there you
Pleiades, okay. Let's try this. Okay, so don't do that. Okay, right click, okay. If I go over here, there's a bright star in the V here, the V shape. What is the name of this star or object?
Taurus.
go. Aldebaran?
Aldebaran. You can click and actually can practice, right? You can left click and right click turns it off. And what is the V shape? What is the proper name of the constellation that is the V shape here?
Taurus.
Taurus, the
Bull.
bull. Very good. Good. Okay. How about over here? What is the name of this star or object? Beautiful orange colored star.
Is that Capella?
Not Capella. No, if you see the 3 stars here that make the
that's
belt.
Betelgeuse.
Betelgeuse, right? And this one must be
Bellatrix.
Bellatrix, right? And this must be
Virgil.
Rigel. And the last one in the corner here.
Dot.
Saith. Yeah, Saith, right. And then over here, the brightest star in the sky is called
Sirius.
Sirius, right? Very good. Now, if I scroll back, I can see the other stars that you were mentioning. This star is part of a loop here. This star is the brightest star in this area of the sky. What is the name of this star or object?
Capella.
That is Capella. Very good. And what is the proper name of the constellation Capella is in?
Ooh, Auriga.
Auriga, the
Charioteer.
Charioteer. Very good. Okay. Jumping over from question.
Yeah, Sean, looking at that, where's the winter triangle, or where's the
Winter hexagon.
hexagon? Yeah, the hexagon.
So remember that these 2 stars count as 1 point.
Okay.
So there's 1, 2, 3, 4, 5, 6.
So it doesn't use Betelgeuse.
No, it doesn't use Betelgeuse. It uses
Okay.
Rigel.
Cool.
Rigel, Aldebaran, Capella. What is the name of this star or object?
Castor.
Castor and
The Procyon, or no, Pollux.
Pollux, right, is the brother. And down here is
Procyon.
Procyon, very good. And we already got that. Okay, so winter hexagon. So what is the proper name of the constellation that has Procyon in it?
Minor, Canis Minor,
Canis
Canis.
Minor, very good. And the one that has Sirius in it?
Canis Major,
Canis Major. And the one that has the brothers in it?
Gemini,
Gemini, the what?
the twins.
The twins. And over here, the major, the big four big stars here.
Orion the Hunter.
Orion the Hunter, very good. Okay. And so if we scroll over here a little bit, I'm going to back up just a bit. I want you to look in this part of the sky right here. And I want to see this backwards question mark. Do you remember the proper name of that constellation?
That's Leo the lion.
Leo
Very
the
good.
Lion,
Leo the
nice.
lion. Good, good, good. And so Leo is over here and Gemini is not too far away. What is the star in the, so remember lions are regal. That's a clue, right? What is the star at the bottom of the backwards question mark?
Regulus.
Regulus, very good. Regal Regulus. And at the tail, what's the name of the tail star?
Ooh, I don't know about that one.
Okay, starts with the letter D. And so you want to try to remember Denebula.
The Nebula.
The nebula, right. Now, in between Leo the lion and Gemini the twins, there is an almost invisible constellation. Does anybody remember what that is?
Cancer.
Cancer, very good. Cancer the what?
The Crab.
Cancer the crab, right? There's a crab in between Leo and Gemini, right? And it's a pretty unimpressive constellation. It's there, you know, and if you're a Cancer, I don't mean to, you know, demean your constellation, but it's made up of dim stars. But if you zoom in a little bit, you start to see a really neat cluster. And that's not quite it. Oh, there it is. Can you see the cluster? And this cluster has a name that you're supposed to know. What is the name of the cluster?
Beehive Cluster.
The Beehive Cluster. Do you remember the M number for extra credit?
Ooh, M32.
Not quite. M44. M44. And so there's a little beehive, right? There's a beehive and little bees buzzing around. It doesn't really quite look as good as in the planetarium. But anyways, that's our Beehive Cluster, M44. Let's see, how do I get the label on that? I could put that, I could just do a search. I go M44, and there it is, M44, the Beehive Cluster, okay. All right, so zooming back out, we got Cancer the crab with the Beehive Cluster in the middle. So under, can you follow what I'm doing here again? Let's see, I'm back to where I was, I zoom back out. So I've got Leo, I've got Gemini, I've got Procyon, and I've got Sirius. What about this bright star right here? What is the name of this star or object? Below Leo. Starts with the letter A. It's called Alphard. Everybody say Alphard.
Alphard.
Alpha.
Alphard. Now, Alphard is a part of a big constellation. And actually, if you zoom in, you can kind of see, here's the head. And it
That's
does a little,
Hydra, right?
that's Hydra,
Hydra,
very
yeah.
good. Hydra the what?
Water snake.
Hydra the water snake. See how Alphard kind of helps you find it. So if you can find Leo, it's below Leo. And it's actually right where it kind of bends down a little bit and then continues on. It's a big, long constellation. Hydra the water snake, okay. Let's zoom around to the north and find what is the proper name of this constellation?
That's the Ursa Major.
Ursa Major. Using these two stars here, you count out 1, 2, 3, 4, 5. Supposed to be this star. What's the name of this star?
Polaris.
Polaris.
Polaris, the North Star. And then you follow this around right here. And we have, what is the proper name of this constellation?
Ursa Minor.
Minor.
Ursa Minor. And the common name?
Little Dipper.
Little Dipper.
Little Bear, actually. And then
Little
the
Bear,
nickname,
yeah.
Oh,
nickname is Little Dipper, right? So you got to keep that straight. These ones have 3 names. So Ursa Major was the proper name. What's the common name?
The Big
is that
Dip-
Big Bear
or the-
then?
The Big
Big
Bear,
Bear.
and the nickname is the Big Dipper. Great, good, good, good. Okay, So let's go ahead and follow the handle this time, and you arc around and you find this bright star. You arc to this star. What's the name of this star?
Arcturus.
Arcturus. Oh, that didn't work. There we go. Arcturus. Very good. And then you spike to this star. What's this star?
Spike to Spicus.
Spike to Spica. Very good.
Spica. Right.
Okay. That's all right. It's good enough. Okay, now Arcturus is the brightest star in a constellation right here. What is the proper name of the constellation? Okay, we'll outline it for you just to show you. Maybe you remember McConnell's, right?
The ice cream cone.
That's the nickname, right? But what about the proper name? It's got a funny
Bootes?
name. Yeah, that's right. Bootes. Bootes. You say both
Bootes.
O's. Yeah, Bootes, right? Bootes. Bootes, the what?
Ice cream cone.
The herdsman. And the nickname is, what's the nickname? The ice cream cone, right? That's the ice cream cone. Okay, and then when you spike to Spica, you come over here. It's the brightest star in a very large constellation. What is the name of that constellation? You remember that?
Where is it?
So it's the spike to Spica. Oh, sorry, Arcturus, spike to Spica, and it's at the end of Hydra. It's called Virgo. Everybody say Virgo.
Virgo.
Virgo the maiden. Virgo the maiden. Okay. And let's not forget a couple of little constellations here. We have this one, and it's made of very dim stars. Let me turn off the lines for a second. Can you see they're kind of dim? The base of it I can see. What's the proper name of that constellation? Okay, it's called
Very
Crater.
scared.
It's called Crater. I know, yeah. Okay. Well, yeah, when you see it in the night sky, it's a little bit better. It's called Crater
Oh,
the
yeah.
what? Crater
The
the
cup.
the cup.
Cup.
And down here, what does the 4 stars make up?
Corvus.
Corvus the
Raven.
The crow.
the crow actually, yeah. So
Oh.
yeah, Corvus the crow. Okay. And I think that might be all of your constellations that you had to know. Oh no, I forgot a couple. Sorry, I forgot. Let me turn to the north again. Okay, so let me turn to the north and talk about a few constellations. What about this letter W right here? Anybody remember the name of that one? Letter W, the W shape. Okay, it's called Cassiopeia.
Cassiopeia.
Cassiopeia, the queen, right? And her nickname is the chair, right? Or the throne, but we'll say chair. And then right next door, we have, actually, I want to show you the way I find it. And if you can go outside and look at the stars tonight even, I don't know, it's supposed to be clear later, so maybe later. Go from the center of the W, trace a line to Polaris, and you pass this star along the way. And that's the tip of her husband. What is the name of her husband? His name is Cepheus. Cepheus. If she's the queen, he must be the
Cepheus the
King.
king.
the king, and the nickname is the little shape there. What's the shape?
House.
A little house. Yeah, put little house if you can, okay? All right, so little house. And then don't forget this one. This is a really neat one. If you look in between the Big Dipper and the Little Dipper, there's a strand of stars that wraps around the Little Dipper and then does a little thing over, and then here's the head. Let's turn off the lines and see if you can see that with me. See the strand of stars in between, jogs over, here's the head. What is the proper name of that constellation?
Is it Draco?
It is Draco. Very good. Draco the
Draco.
dragon. Draco the dragon. Okay. And I think that is all of your constellations for tonight. Okay, great. So we are gonna stop that, but you guys should be practicing. At some point, I do have to give you a quiz, and you know, I'm gonna do my best to figure out how to do that. I don't really know what to do on that actually. Got to figure that one out, but we will figure it out, and we will be take that quiz at some point. Okay, so meanwhile, let's go ahead and let's get out our workbooks. Okay, so if you can find your workbook, find page number 34A.
Sean, can I ask you a question?
Sure, of course.
On, I believe it's 25A.
Uh-huh.
Is that the only time that we are able to see Ursa and Draco? Because I looked at all my other constellations and stars
Yeah,
of
it's the only one it
spring.
shows up on. And the reason is Draco is one of those constellations that orbits around, it's very close to Polaris,
Mhm.
right? The North Star. So we call it, if you look at page 25A, what are the names for constellations that go around the North Star? They're called Northern Circumpolar constellations. You remember learning
Mhm.
about those? And so
Yes.
depending on where you live, you can see, some more or less, right? We don't see very many. We only see a few, remember? We only see a
Mhm.
few of those constellations, just a handful, maybe 6, depends on if you count it or not. If part of it goes beneath the horizon, should you count it? And we have like 6 maybe that don't go, that some of it is always going to be appearing above the horizon. So
Okay,
those are
'cause,
kind of
yeah.
special. Yeah, so Draco and Cassiopeia and Cepheus and Ursa Major and Ursa Minor only show up on those pages.
Got it. Okay. Yeah, because I kept looking to find the correlation of where they would be on here.
Okay.
And anyways, I will.
You know where you could, what you could do is if you use your planisphere from your lab workbook, from your lab folder, you can actually see all the constellations there. And then you can see that connection where the other ones fit in. I would try that perhaps. That might be another little tool for you. Or get an app. Do you have an app yet?
Yeah, I have Stellarium, and that's been amazing.
Okay. Isn't it amazing? It's so fun. So you could just have fun with it. And actually, I'm going to give you another activity to kind of play around with it because we're not meeting, right? Actually, I'm so bummed, you guys. I feel like you're missing out on some things, but everybody is, right? Everybody is missing out on something. I feel so bad for the people who are graduating this June and May who aren't going to get to walk in a graduation ceremony. It's like, are any of you guys graduating? No? Okay. So hopefully everything will be back. You're graduating.
You
Oh, I'm so
are?
sorry. Honestly, when they told us, we're like, what about our robes? No robes.
Can't we do
You
a
know what?
social
I
distancing
would
every
have
6
cheered you
feet?
on so loudly, Freeland, just so you know. I really enjoy that graduation. I feel so, proud to have been your teacher, and you're going to move on without coronavirus, you're going to be fine. You're going to move on. I just, I feel like we should do a do-over or something and have our ceremony so we can have a party and have some fun. But anyways, yeah, coronavirus time you're going to remember this for the rest of your life. Coronavirus time. Okay. Okay, let's talk about happiness. Let's talk about page 34A. Turn to page 34A for me, and then let's take a look. So we have the definition right here. Actually, I'm going to ask you to define it, but there's actually 2 different figures, one on the top and one on the bottom. And there's some words that you have to understand. Let's take a look at the top figure. It says configuration of a superior planet. So we are going to compare the planets, in this case, to Earth. And there's going to be a superior planet. What do you notice about the superior planet? Is it closer or further from the sun?
Further.
Further away, right? So are there any planets that are superior to the Earth? Which planets are we talking about that are superior to the Earth? Let's do them in order.
Oh, God.
What's the first planet further out than from the Earth? Further away from the sun than the Earth?
Further away?
Yes.
Pluto.
Well, that's the furthest away. How about starting with the Earth? Which one is the next one?
Saturn.
How about
Mars.
Mars, right? What would be next after Mars?
The belt.
Well, that's not a planet, though. We don't need to worry about it.
Jupiter.
Jupiter, okay. After Jupiter comes Saturn. After Saturn comes Uranus. Oops, Uranus. And after Uranus comes Neptune. Okay, so those are the superior planets to the Earth. Now, what if I asked the question, which planet is superior to Neptune? What's the answer?
Uranus.
No.
There aren't
planet.
any.
Oh, no.
Okay, nobody. Okay, which one is superior to Jupiter? Which ones are superior to Jupiter?
Saturn, Uranus, Neptune.
Yeah, so anybody who is further away from the sun, than you are, is considered to be a superior planet. So there's some words. We got to figure out these words, right? So a couple of little ideas. Number one, what if the planet is lined up with the sun? What is that called? The planet is over here and is lined up from our position in the Earth. We see sun and then the planet. What is it called?
Cepheus.
A conjunction. Okay,
A conjunction.
conjunction. So in fact, another word for that is syzygy. Remember the word syzygy? So when the Earth and the sun and the superior planet line up, that's called the syzygy, right? Now, do you think we can see this planet when there's a conjunction? Can you see it?
No, the sun.
Not
No.
at all. Yeah, the sun is going to, if it's perfectly lined up, the sun will get in our way. But even if it's not perfectly lined up, it disappears because it's too close to the sun. And so every year, the planets will disappear when they have a conjunction with the sun, right? So every year for a short while, the planet will disappear from our night sky. And the reason is it's just too close to the sun, okay? Now, there's two places on the figure that are called quadrature. What does this mean? What's quadrature? And I should mention something, by the way. You learned that when the sun is in the middle, what is the theory called, or the model where the sun is in the middle of our solar system?
Heliocentric.
The heliocentric, right? So if you remember a couple of ideas, pretty simple ideas, but if you look at the orbits of the Earth and this other planet, when you look at them, which one takes more time to go around the sun? The Earth or the other planet?
The other planet.
The further out you go, the longer it takes you to orbit the sun. The other idea is the speed, the orbital speed. Which one is moving faster, the inner planet or the outer planet? Which one?
The inner planet.
The inner one is moving faster as well, right? Not only does it take less time, but it's moving faster, okay? Both things are true. Okay, so if I were actually talking about who passes, which planet is passing the other planet, is the Earth passing this one, or is this one passing the Earth? Which one is happening?
The Earth is passing that one.
The Earth, which is in the inner orbit, is going to be passing this other planet. So actually, which one of these situations, quadrature, opposition, or quadrature, is going to happen first as the Earth is orbiting near this planet? Which one happens first? Which one of these? The top one? Okay, so the Earth actually has already left the planet behind, and I would say that happens last, right? So if the Earth is here and the planet is over here, it is already past the planet. Do you follow that?
Oh, I see. Yeah,
Okay.
you're saying that.
What's this one here? The Earth is in the process of passing the planet. And which one is this one? The Earth is approaching and is on its way to that, to passing the planet. So let's put them in order then. Which one happens from our point of view on Earth first? Which one happens first? This one happens first, right? This happens second, and this happens third. Does that make sense? From our point of view on Earth, we see the planet coming. We pass the planet, and then we have passed the planet already. It's behind us. So from our point of view on Earth, this happens first, this happens second, this happens third. Are you following now?
No, because wouldn't we be spinning towards the
Okay,
east?
right. So let's say that we're on the Earth, we're right here.
Right.
And we see the planet coming, but we haven't passed it yet. Where is it? Well, we're going to catch up to them. They are in front of us right now, but we are going to catch them. So we see this happen first. The Earth
So
keeps going, and as it's passing, we're going to shift back, and the Earth will be here, and the planet will be. So I'm taking the point of view of the Earth, and I'm asking
Right.
which one of these situations happens first. And the answer is this one here is going to happen first. We're going to see the planet coming up. Then we're going to pass the planet. And third, the planet will be behind us in orbit. So that's a little, don't worry too much. I just wanted to see if I could throw that in. I tried to teach that last week and it didn't come out very well. I don't think it came out very well this time either. I'll show you another picture in a few minutes and I think you'll understand it, okay? But let's talk about what does it mean to be quadrature? What does quadrature mean? Do you see what's happening with the sun and the Earth and the planet? What is it?
It's a quadrant.
It's a quadrant.
It's
Yeah, what's the
creating
angle?
quadrants.
Yeah,
90
what's the
degrees.
angle? A 90-degree angle, right? And there's also a 90-degree on the other side, right? It's 90 degrees either way. So there's two quadratures, one where the planet is ahead of us in orbit, and another one where the planet is behind us in orbit. Does that make sense?
Mm-hmm.
Okay, so don't worry about the timing then. Just how about this one? This one is the planet is ahead of us in orbit by 90 degrees. This one, the planet is actually lined up with us, right?
Okay.
Its opposition means what? It is exactly opposite the sun. And the third one, quadrature, is when it's 90 degrees behind us in orbit. Okay, now I do want to take one more moment here, and I want to talk about this special opposition here. This is a very special point. Why is it special? Well, what time of the day or night would this opposition planet reach the highest point in the sky? What time is it when this planet is crossing the local meridian, right? What time does it crosses? So I want to put crosses the local meridian. Remember that word? The local meridian is the middle of the sky. What time does it cross the middle of the sky?
It'd be midnight, right?
Exactly, that's right. Because it's across from the sun, you want to put it crosses the local meridian at midnight. So if I asked you, when do you want to observe a planet when it's at opposition? The answer is it will be highest or directly overhead at midnight, right? So that's kind of the very best time to look at it. Here's another question. What do you think will happen to the size of the planet as we observe it at these points here? Which one of them will the planet appear the largest?
One.
Opposition.
At opposition. Because why? Because it's
The
closest.
to it.
Yeah, this is actually as close as we're going to get. So if you want to see Jupiter or Saturn, the best time to observe it is at opposition. And so that means what? Well, if it's highest at midnight, what time does it rise? This is kind of like phases of the moon. What time does the phase of the moon rise if it's highest at midnight?
The
Six.
evening?
It rises at sunset, about 6 p.m. It's highest at midnight. What time will it set?
Sunrise.
About
6 a.m.
sunrise, 6 a.m., right. So this is just something for you to keep in mind. In the future, you will get a chance, and I hope you guys will come to a star party, even if you're not in my class, and you can still see these things. This summer, is going to be wonderful. We're going to be able to see Jupiter and Saturn. I think it'll be really fun. So once the quarantine is over and you want to celebrate, come to a star party and come look at these things that you were supposed to be able to see. Okay. But anyways, it'll be beautiful. It'll rise at 6 p.m. It'll be in the early evening sky. It'll be highest at midnight. It'll set at 6 a.m. in the morning. So you'll see it all night long. It'll be really wonderful. Okay, so that is superior planets. We talked about which planets are superior. We talked a little bit about quadrature, and we talked about this opposition and the timing. Let's jump to the lower part of the page now. And here we have the inferior planets. So what do you notice? The Earth is now in the orbit around the sun, which is the outer circle. The inferior planet is closer to the sun. There's more words here, by the way. There's more vocabulary. But number one, which planets are inferior to the Earth?
Venus.
Venus.
And Mercury?
And
Venus and Mercury. So Mercury and Venus are the only two. And that's kind of important for you to know. You want to know that only two planets can be considered inferior, and that means they are closer to the sun. So actually something kind of fun about them is both Mercury and Venus have phases. And when I say phases, everybody has phases, by the way, but these ones have all the phases. These ones up here, we're going to learn, only show up as full, maybe as a gibbous, right? But basically, they're always going to be full. And these ones down here are going to exhibit all of the phases that you know, which means waxing crescent, first quarter, waxing gibbous, full, waning gibbous, third quarter, waning crescent. All of the phases that you learned with the moon, Venus and Mercury are going to have those phases too. Okay, so here we are on Earth. Here we are on Earth, and we're looking at this inferior planet. And so we want to say, what is it called when it lines up with the sun? What is it called?
It's called conjunction.
It's still called conjunction, but now we have two kinds of conjunctions, right? We have, and by the way, it's still syzygy. If it's on this line, it's called a syzygy. That's another word you could use. But what do you call it when it's between the Earth and the sun? You can read the word. It says inferior conjunction. And when it's on the opposite side of the sun, it's called a superior conjunction. Now, I want to see if you could make a connection. What phase would you guess Mercury would be if it's at inferior conjunction? What phase would it appear to us on Earth?
Full. Oh, no. Yeah, full.
So how much of it are you going to see lit up?
Are you going to see
None.
none of it? Yeah.
You're going to see none of it lit up. So what's the phase?
New.
It's new, right? And over here is going to be what?
Full.
So let's make a little note to ourselves. It's new here and it's full here. Okay, and we'll worry about the other ones later. Okay. All right. So I want you to imagine you're on the Earth and you're looking up at the sun. Okay. And it's right above your head. What time is it?
12 o'clock.
It's 12 o'clock, right? Oh, sorry. We're looking at the sun.
It's noon.
Okay, so if I look at the sun, I want to turn the picture. Actually, I want you to think about the sun being directly overhead, right? The sun is going to cross the sky, right? It's going to cross the sky. I didn't draw that very well. Sorry. Going to cross the sky, and if it's over here, which side of the sun is it? Is it on the east side or the west side? Which one is it?
It's going to be on the west.
West side.
So, well, the sun is going to rise over here and cross the sky and set over here. So what is over here? This
Right
is the east. The east. And over here is the west. It's all about the sun, right? If you're to this side of the sun, you're east of the sun. And if you're this side, you're west of the sun. And so this is actually kind of a fun little thing to note. Actually, hold on one second. I'm going to actually show you guys something kind of important. Oh, you know what? I'm just going to show you. Let's go ahead and jump onto Stellarium. And I'm on the Stellarium, and I wanna look for the sun. I can't see the sun right now, so I'm gonna go ahead and change the time. Go back till the sun is up. Okay. Now I've turned off the atmosphere. By the way, if you don't know how to do that, this is there's a button right down here, and you just turn off the atmosphere. And so I have the sun. And by the way, there's Mercury. Hey, look at Mercury. And there's Venus. Look at that. Venus, Mercury. So I'm going to turn on a line for you to help you see something important. I want to turn on a line here called the ecliptic. Okay, you guys might have remembered that, the ecliptic. Anybody remember the word ecliptic?
I do.
Mm-hmm.
What is the ecliptic? Okay, so actually I just realized, I think I want to make sure you know that word. So I'm going to go ahead and write down ecliptic for you. The ecliptic.
Sean?
Yeah.
When you share yours, is it possible to make it big, like the way, instead of a small view, or maybe speaker view? I don't know.
You
there it
need to
is.
go to speaker view and then,
Got it.
yeah, pin my video if you want, okay?
I don't know what that means. But...
If you hover over my video,
Mhm.
there's 3 little dots. You see the 3 little dots? If you hover over it with your cursor and you click pin video or spotlight video, I think, one or the other. Actually, I don't know if you could. Oh, did I just do it for you? Do you see is the picture a little bit bigger now?
Oh, it is. Now that I did, instead of gallery view, I did, anyways, I can see it a lot bigger.
Okay, good. Okay, so the ecliptic, there's 2 different things, right? Actually, I'm going to remind you because I think you guys might have forgotten. There is, if you look at the sun is the middle of our solar system, and the planets orbit around the sun on this mathematical plane. And what is that plane called? The ecliptic plane. Right? That's this plane. Remember that when we have a solar eclipse, the moon is passing through the ecliptic plane, right? But there's another word, and it's going to be the path the sun follows through the stars. So just to remind you something, if I were to look, we did on worksheet 6, 6A, I have south right here. I had some numbers, 10, 20. Am I really going to do all this? I don't know. Why not?
Yes.
You guys you have any place to be? I'm just kidding.
Oh, yeah. Uh-huh.
That was a joke, sorry. That's a rhetorical question. All right,
Nothing
you're supposed to be with me. Okay, here we go. And over here I have the east, and over here I have the west, right? And remember that there's a path that starts in the east, gets up to, in Santa Barbara at least, about 56 degrees, and then comes back down. And this is the celestial equator. Okay, that's the celestial equator. So is the sun above, below, or on the celestial equator? Well, the answer is at different times of the year, it's at different places. So we see the celestial equator when we look in the horizon, we see it as an arc like this. It turns out right now, is the sun above or below or on the celestial equator right now, today?
Be below.
Actually, a good guess, but wrong. It's above,
above.
right? On March 21st, it crossed over and is now higher. And on what day does it reach the highest point above the celestial equator?
The
June
vernal
21st. Solstice.
vernal
the summer solstice.
June 21st. Yeah.
Yeah, so it crossed over on the vernal equinox, and then it's going to get up to about 79 degrees on the summer solstice. So right now it's above the celestial equator. Okay, so I'm going to actually switch gears. I want to show you a different picture. I want to show you, I'm going to change it. And on the celestial sphere, here's the celestial equator, right? I've unraveled it from the sphere. I just have a flat line. And what happens is the sun goes above and below and back up again. And so what date does it cross the celestial equator right here? 3/21. What day does it come back to the celestial equator? 9/21, right? What day is it highest above the celestial equator?
6/21.
6/21. What day is it lowest below the equator?
12/21.
12/21, and we're back to 3/21. So this path that I'm drawing is also called the ecliptic. Does that make sense to you? Sometimes it's higher, sometimes it's lower than the celestial equator. Sometimes it's above, sometimes it's below. Remember the arcs that the sun takes, right? There are different arcs through the sky, right? I'm not drawing it very well, but you get the idea? So it can arc below the celestial equator or above the celestial equator at different times of the year. Okay, all right, so that's the ecliptic, and I've shown that to you. So I want to show you again what that looks like. So we have the red line is the ecliptic, and I want to show you a little trick here. I'm going to click on the sun, and then there's two ways to do it. I can either press the space bar, or I can go down here, and there's a little thing right here. It says center on the selected object. Okay, and so it's centered it. Okay, now it looks a little distorted, but anyways, I still want to do it. Let me do it anyways. Okay, so what I want to show you is, let's take a look at Mercury and Venus. Do you notice how they're really close to the red line? I want to go ahead and advance time, and I want you to see that they always stay close to that red line. They're always close to that red line, but they may not be exactly in the same place, right? In fact, they are moving near the sun, always near the sun. And so they are always orbiting near the sun. They will always appear near the ecliptic. Did you see every month what comes by once a month?
The moon.
The moon comes by. Now, it turns out all the planets are going to be on the ecliptic. They are always on or very close to the ecliptic. Here comes the planets I mentioned to you, right? Which planets did I say are going to be good, right? Venus, here comes Saturn and Jupiter. Oh, yeah, look at them. Look at how close they are, by the way. They're
For
right
me,
next
it's
to.
frozen.
Oh, my gosh. Actually, you guys see something exciting happening?
No.
Look at this. In the future, what's going to happen? There's going to
They're
be.
gonna cross over each other.
Oh, what's that called when they line up with each other? Who knows? Oh my gosh, look at how close they are. That's awesome. Oh my gosh, look at the date. Look at the date. Who knows the date?
Oh, that's
Yeah.
the winter solstice.
Is that
Winter
crazy? What a lucky coincidence. They're going to be closest on the winter solstice this year. How exciting. What a fun thing to notice. That's neat. Okay, that was a little side. I didn't mean to do that. Sorry about that. But it's just, it's kind of cool. Look at how close they are in the sky. So back to the sun. So we just saw that the planets are always close to the red line, which is called the ecliptic. The planets are always close to it. Now I'm going to show you something really neat that I just discovered because I wanted to teach you better. I'm going to go to the search window and I want to do something. I'm going to, please write this down. Solar system, system observer. Look at this, okay? And hit that. And it just made a little, I don't know what that is, but it's what something, I don't know what that is. And now you need to know how to change home location. So what you're going to do is type Alt G. No, never mind. That's the wrong. Control G. Okay, so what I've just done is I've changed my home position. So did you write that down? Solar system, and I'm going to show you how to use this. Observer, and then Control G to change your home position. And what we're going to do is we are actually going to look for the sun again, but this time you're going to see something that we are actually kind of, you can see right here how far away we are. We are a distance 467.921 AUs, right? And I'm going to do a couple more things. I'm going to go into my sky and viewing options, and I'm going to show solar system objects. I'm going to show planet orbits. And I'm just going to show the planet orbits. Okay. And show planet markers. Okay.
Do you have a different version of this that we do?
I don't think so. I just oh, maybe I do. Does yours not show this?
Mine is
Yeah.
different too.
Okay, well, so now you can see something. I'm looking down, I'm going to zoom in. And when I zoom in far enough, I start to see the orbits. Okay, so the first planet is
Mercury.
Mercury. The second planet is Venus. The third planet is Earth. What's the fourth one? Which I can't quite see. Mars. Okay. And now what I'm going to do is I'm going to actually just speed time up, and I'm going to let time progress, and I want to start seeing them move. And you can see them move, right? So I can't see Mercury very well. Oh, there it is. Okay, there's Mercury. So Mercury is moving the fastest, and you can see there it is passing Venus. Right? Or Venus is moving faster than the Earth, right? So let's see if you guys remember some words here. By the way, let's look up at the sun. Which side are Mercury and Venus on? The east side or the west side? Which side of the sun?
East.
That's right.
West side.
These are called Eastern. These are called Eastern elongation. Eastern elongation. And now let us speed up again. Actually, maybe I should just click forward. Okay, stop. Okay, what is it called when Mercury lines up with the sun?
Coordination, conjunction.
An inferior conjunction.
Inferior.
Right? Inferior conjunction, right? And so actually, I wonder if I could just step forward. Yeah, maybe that's easier because then I can stop it.
Sean?
Yes.
When Mercury passed up Venus right there and then, would that be the retrograde as soon as it passes it?
Oh, that's a good question. As it passes Venus, if you were on Mercury, you would see Venus going retrograde, correct?
Okay.
Okay, that's true. But actually it means a little bit different when you ask the point of view of Mercury or from the Earth or Venus. It's not necessarily retrograde.
Right.
I'll show you prograde and retrograde in a few minutes, okay? All right, so let's keep going. And actually, well, I don't know which one's gonna get there first. I think Mercury, actually, never mind. Okay, so now, is Mercury across from the sun? Pretty much, right? Okay, so what is this called?
Superior conjunction.
Superior.
Superior conjunction, okay? And then you can see, by the way, and Venus is still Eastern elongation. And we're gonna go ahead and get to Venus being between the sun and the Earth. What is that called?
Inferior conjunction.
Inferior conjunction, okay? So we're looking from the point of view of an observer who's about 500 AUs from the sun, actually about almost 500 AUs. And again, we can let time speed up. And there's Jupiter moving very slowly, Venus moving quite a bit faster. Earth is not as fast as Venus. I don't know why I can't see Earth.
Mm-hmm.
I don't know, disappeared. I can't see it. But anyways, it gives you the idea, right? These are the orbits of the planets. Okay. All right. So let's stop. Now, how do I go home again? Let's see. I want to go home. I want to go back home. I don't know how to do that. So what I'm going to do is I'm just going to turn off the software and just restart it because it starts me home. It's easier to just do that. Sorry about that. It works, right? I should know how to do it. I just don't want to take the time to do it. I may be using an older version of Stellarium. Actually, I just saw it's
We use the web.
0.183. It should have almost the same stuff though.
We use the web one, so I think there is not like complete as if we download.
I'm sorry, say it one more time.
We use the web version, so I think there is not like isn't.
Oh, no,
complete.
no. If you have to use the web version, you're going to miss out on some things. It's unfortunate. Is it really not possible for you to download the other one?
I think it's like pretty heavy.
Yeah, if you have to use the web version, you're not going to have all those features, unfortunately. Yeah. So try to, if you can, just try to find a way to download it. You can get it on your phone even. Let's see, I'm going to screen share again and then go back to the story I was showing you before. Okay, so I'm going to go ahead and go back and try to find the sun. Oh, the sun is up, sorry, okay. Sun is up, okay, and turn off the atmosphere, okay, and I'm going to center it. And I'm going to turn on the ecliptic path again, okay? So the ecliptic path markings, ecliptic. Okay, and so what I want to do now is focus exactly on, actually, you know what? I'm going to go back in time until the sun is directly over south or pretty close to that. Actually, it's not directly. What time? Oh, it's pretty close. Let's see, what time? What is the azimuth? 179. Actually, this is pretty darn close to directly overhead. Okay, so the sun is directly over south right now. And this path, you can see the path is to the north of east over here and to this, it's above or below the celestial equator. Never mind, forget that. Look at Mercury. Let's look at Mercury. That's what I want to look at. If you look at Mercury, or actually Venus, Venus is easier to look at. Let's look at Venus. If you look at Venus, is Venus to the east or to the west of the sun?
To the east.
East.
Is to the east. So what would you call that? Eastern or western elongation?
Eastern elongation.
And what about Mercury, east or west?
Western elongation.
Western elongation. Okay. So we have another name for these that you have to be aware of. So if I look at these two objects, which one of them will appear first when the sun is rising? Will this one appear first or this one appear first?
Venus.
Mercury will appear first.
Mercury.
Okay, so let's go back in time. And the sun is not up. Is Mercury up?
Yes.
Mercury is up, right? The sun didn't come up yet. Mercury came up first. So if you were not in an astronomy class, an astronomy student, you might be confused and think it was a star. What kind of star would you call it if it's up before the sun?
Morning star?
This is a morning star. So what is the configuration of a morning star? Is it eastern or western elongation?
Western elongation.
The western elongation makes Mercury a morning star. Now, let's go ahead and advance all the way to the end of the day. Let's look over here to the west. And we're going to watch, I messed up. There we go. Advance time all the way until the sun is set. And what do you notice about Venus? Is Venus still up?
Yeah.
Venus is still up. So it's to the east or to the west of the sun, we said?
East.
The east. Is it a morning or evening star?
Evening star.
It's an evening star. So just for one moment, let's go back to our worksheet, our workbook. And I want to make a note right here. When it was an eastern elongation, like we just saw with Venus, what kind of a star was it?
Evening.
Can you make a note to yourself? This is when it's an evening star. And over here, when it's western elongation, what is it going to be called?
Morning star.
A morning star, right? So there's actually, this is the reason why we can see that, okay? So we'll come back to this greatest in just a moment, but for now, just worry about the elongation. Okay, so back to my screen share, back to Stellarium. I'm gonna do something that you can't do normally, and that is I'm gonna actually, instead of watching, actually I should watch Venus, just a second, I should watch Venus. Back it up just a bit. Okay, I want you to watch Venus as I advance through time. So here's Venus, watch Venus. Eastern or Western elongation?
Eastern.
Eastern.
Eastern, okay. But watch as time goes on, you guys did this, right? What happens is Venus stops moving to the east, and actually we see it going retrograde now. And now what is Venus, Eastern or Western?
Western.
Western.
Western, right? And as it gets further away from the sun, the elongation is increasing, right? Elongation is the amount of time that that object appears about, in the sky before the sun rises, right? So we see Venus Venus rising, rises pretty early. And the total amount of time that it rises before the sun comes up is the amount of the elongation, right? So you didn't have to be very fancy, just kind of measure time. The length of time Venus is in the sky before the sun is the amount of the elongation. What happens as time goes on? What's happening to the elongation? Is it getting bigger or smaller?
Bigger.
It's getting bigger. It's getting further away from the sun. Now, in astronomy, we actually measure the angle, right? This angle, and I'll talk about that in a few minutes. But the bigger the angle between the sun and Venus, the greater the elongation. And at some point, it gets as far away as possible. That's another cool conjunction, by the way. And then you'll notice that it actually starts to get closer to the sun again. Okay, so it actually is going to start getting closer to the sun again. So that's decreasing the elongation, okay? Getting closer. All right, you guys get the idea? So there's this time that we call when it's greatest elongation, and that's when it is the furthest away from the sun, right? So I'm going to go ahead and stop this for a moment and look back at my diagram. And I want to actually draw a picture for you. So if you wouldn't mind, maybe you could draw this picture as well. The question is, where should the inferior planet be in order to have the greatest elongation? So I'm going to show you the sun here. I'm going to put the first planet and then the second planet. Okay, so we're going to be on the Earth. We're going to actually be on, we're going to be here, right? We're going to be on this planet. And the other planet is going to ride around on this inner circle here, okay? But the question is, where would it be so that it appears as far away from the sun as possible? Now, a lot of times students get a little confused by that, and they think that this would be the place where you would be as far away from the sun as possible when you have a 90-degree angle. Does that make sense? Do you understand why people would be confused by that? That might be the answer. But what I want to do is show you something, a very simple idea. If I draw a line between the planet at that point and the Earth, right, you can see that there were actually a bunch of places that where it would have been further away from the sun, right? This angle is not the biggest angle after all. So when do you get the biggest angle between the sun and the Earth and, let's say Mercury?
45 degrees?
Line, it's like tangent.
Not at 90 degrees, actually. It's
45?
Not at 45 either.
I don't know, like
But
70.
somewhere right around here, actually, right around here is as far away as you can get from the sun. So I want to show you something special. Yes, that's right. Who said that? This is called the line between the Earth and that point right there that just touches the circle in one spot. If you guys remember in math, I want you to write the word down. It's called a tangent line. Have you guys heard that before?
Yeah.
Remember the tangent? It touches the circle at just one place. And this is going to be the biggest possible angle, right? You can't get further away from the sun at that point. So hopefully you've drawn a picture like this in your notes, because I want to actually tell you one more neat detail. If I draw a line connecting the sun and the planet at this point, I want to show you something very interesting. Does anybody know what the angle between a tangent line and a radius line is?
90
90.
degrees, right?
It is 90 degrees. And that's kind of a neat thing. It turns out that when the planet is at the greatest, is this eastern or western elongation?
Eastern.
Eastern, right? So GEE, greatest eastern elongation. And then how would you get the GWE, right? You do the tangent line on the other side, right? And don't worry that it's not a perfect circle. I'm still gonna just draw the best I can. That's pretty good, but something like that, okay? It's gonna be the greatest western elongation. And when you do that, you get a 90-degree angle. Sorry about that, okay? That's kind of cute, right? So when you're as far away from the sun as possible, this planet as seen by the Earth, you actually make a 90-degree angle there. So that'll come back and we'll talk about that in a minute, okay? All right, so back to Stellarium. Let's do something that you can't normally do with the sun. And that is, I'm gonna actually make the sun rise. I'm getting confused, here we go. I'm gonna go ahead and center the sun.
I can see your screen.
Oh, you can't see it? Oops, sorry, hold on. I forgot to share. Thank you. Let me know as soon as I do stuff like that.
Okay.
Thank you. Now you see it, right?
Yep.
Okay. What I want to do is I'm going to zoom in. Actually, you know what? I'm sorry. I'm changing my mind. I want to actually zoom in on Mercury. Okay. So at this moment, I forgot. I want to zoom in on Mercury. So I'm going to zoom in. I want you to tell me, what phase do you see? What phase do you see? Anybody?
See gibbous.
I say
waning
gibbous too. Everybody see it's more than halfway lit up?
Yeah.
That's gibbous. Okay, cool. And now I've got my little time and date down here. If you forgot where that is, it's right over here. Time and date. And I'm going to go ahead and just watch Mercury change. I want you to tell me, is it getting more full or less full? More or less?
More.
More, that's right. Oh, what was that? That was funny. And now, how about that?
Very full.
It's still full?
Now-
Okay.
No,
How about now?
no, not
Waning
anymore.
gibbous.
Less,
Nope.
less. How about
Now at a
now?
half.
About a half, right? And now, how
Waning
about this?
half.
Crescent.
Waning
Crescent.
crescent.
Waning crescent. Okay, good. Yeah, you're using language. Okay. Did you notice it got a little bigger, by the way? Okay.
Mhm.
And what would you call that?
No,
New.
a new.
That's a new, right? So where is Mercury located?
At
Right
opposition
there.
Right in front of the
or
sun.
inferior conjunction.
Inferior conjunction between the sun and the earth. Let's zoom back out and let's see, in fact, that that's the case. Where's the sun? Oh, there it is. Okay. So you see, we're very far away. It's not perfect. In fact, it looks like maybe one more day it would even, but you see, Mercury doesn't go right in front of the sun every time. So if you look right here, does it still look pretty new to you? Let me go one more day. It's, oh, now I see a little hint of light. Do you see it? So definitely for like 1 or 2 days, it's, oh, I still see a hint of light. So it's actually this day right here. This day and this day. These are the best days right here. So anyways, what I want to do is I want to watch Mercury and look what happens when I go advanced time. Look, what do you get?
Crescent.
A waxing crescent, right? A little bit further, what do you see?
Half or first
About
quarter
half
Mercury.
first quarter, right? Like a first quarter. And now what does it look like?
Waxing gibbous.
Gibbous.
Waxing gibbous, right? And so you could watch it go through these cycles. And now it's waning. And it's back to new.
Why
right?
does it get so small and large?
Oh, I don't know. I wonder why. Why would a planet get bigger or smaller, Erica?
Is it just because its rotation is getting closer to us?
That's right. In its orbit, it's getting closer or further. When was it biggest?
Hmm.
When it was
Inferior
new?
conjunction.
When it was new
Yeah.
or full?
New.
And when is it smallest?
The full at the.
So now look
superior
at your
conjunction.
orbit. Look at the little configuration thing. What do you see? When is Mercury closest? Okay, so I'm going to go back to this diagram for a moment,
Mhm.
right? When is Mercury going to be closest to us?
Inferior
At
conjunction.
inferior conjunction, right? And it's furthest at superior conjunction. Okay, so we're going to do a worksheet right now. You guys are ready. We're going to observe Mercury for a while, for a long time. And what we're going to do is we're going to figure out something kind of important. So let's go ahead and flip to page 33A. And I am going to be doing this worksheet with you. Okay, so you guys are going to definitely fill in this worksheet. Determining the inferior orbit, inferior planets, sidereal period. Okay, let's underline that word. You need to know what that means. Does anybody remember what that word means? Sidereal period.
Isn't that what the stars?
What was it?
With the stars has to do with the stars?
Yes, that's right. It is relative to the stars. Okay, relative to the stars. And what is the synodic period?
Relative to the sun.
Relative to the sun. And remember when we looked at the sun, we said that the sun's rotation had a synodic period because where were we observing the sun?
There.
From the earth, right? So another way to think about synodic is as seen from earth. Okay, so what does the synodic period mean? The time it takes to go through a complete cycle as seen from the earth. Okay, so what's our planet? We are going to pick Mercury because it takes less time. We're going to have fun with Mercury. Mercury, write that down. Mercury is going to be our planet. And we're going to start off by doing the synodic period. Okay, now, actually, I think I should probably just go back to this year again because I've already kind of messed it up and I'm forward in time. But I'm going to go back to the current date. Give me 1 second. So what's the date today?
4/13.
4/13, okay. And then I will share that with you, okay? And so we are on 4/13. And actually it looks like we've already passed the new Mercury, but let me just go back and to the previous one, okay? We're gonna write down the date and we're gonna see how long this takes. Okay, does that look pretty good to you? Pretty good? Okay. Okay, that's too far. Okay, and that looks pretty good to me. I think that's it. It's somewhere between 225 and 220. I'll put 226, okay? So you want to write that down? 226, February 26th. Write that down. 226, 2020. And what we're going to do is we're going to watch it go through the full cycle again. And I'm just going to watch it, right? Waxing, first quarter, gibbous, waxing crescent, gibbous, full. Oh, what the heck was that? Did you see that?
The flash.
What the heck? It flashed. Why? Oh, this time it went behind the sun. Okay. What was that called? What's it called when it lines up with the sun again?
Eclipse.
No, not an eclipse.
No.
When the planet is lined up with the sun, it's the conjunction. Which kind of conjunction? Yeah, the sun eclipsed the planet. That doesn't count. Yeah.
Yeah.
It's
No,
called
it's a superior conjunction.
a superior conjunction. Very good. Okay. And now we're okay. It's back to full, right? And keep going. Watch. Oh, here we go. Third quarter and coming back towards. Oh, it's a little big, huh? Okay.
Mhm. Oh, there it is.
I went too far. Okay, back. Something like that. Think about that. Okay. So here it is, about 6/29/2020. Now, are we friends or are we going to be exact? Which one? You want to be friends or exact?
Exact.
You want to be exact. Okay. I was hoping you were going to say friends, but that's okay. That's all right. No problem. Actually, let's see. What do I do? Oh my gosh. Okay. Well, hold on. Did you write down the two dates?
Yes.
Okay. So then I'm gonna cheat because I can't do this in my head.
Mhm.
I'm gonna go. I want to know how many days there are between those two dates, right? So I'm gonna go to Google, and I'll show you guys what I'm doing here. I'm gonna go to the Google, and I type this in, days between the dates, and there's a calculator right here I'm gonna go to, and you type in the first date. And so we had 02, and then 2026, and 2020. And the second date was 06, 29, 2020. Okay, and then calculate. Okay, so the answer was 124 days. Okay, so can we write that down? All right, so what is the synodic period? Okay, why would you make it so hard? Can we make it easier?
Yes, friends.
Okay, all right, can we be friends?
Friends.
Okay, let's be friends. So if you notice, it's almost perfect. It actually worked almost perfectly anyways. But I would rather actually cheat a little bit, and I'm going to tell you why. It's not perfect, but do you notice that the end date almost landed perfectly on the same number?
Mm-hmm.
So how many months was it?
4.
It was just about 4 months. So let's put that down, 4 months. Okay. All right. Now we actually, if you want to put in parentheses, it was really 124 days. That was the real answer. Okay. Now it turns out you actually should be doing this a few times. I just realized, you know what? I'm gonna show you. Let's do it again, just for fun. Let's do it again. So we do it again. And what's your prediction? When do you think it'll come back to new moon again? New Venus, new Mercury again? Predict?
Wait, do we have a start date?
Yeah, the 6/29.
So it'd be October 29th? Or
10/29, 10/29. Okay, so here we go. And look at this, 10/24/25. Okay, and let's do it again. Okay, do it again. And any predictions where it's going to come back?
February 25th?
Yeah, just about the same time, right? Just about. So that's our prediction, right? So actually, it's not perfect. Okay, it's the 7th. Okay, so it's not perfect. So anyways, that didn't quite work. So it's not quite, yeah, it's a little bit less. So here's the problem. Mercury does something a little bit different every time, just a little bit, because it has a highly elliptical orbit. But it turns out it's very close to about 120 days, about 4 months. Okay, so Yeah, not perfect, but pretty close. Okay. So the reason I want to tell you that is, well, I want to do something easy. Okay. So now let's draw a picture, and I'm going to show you something important. Actually, I don't know why. I always draw the Earth on the other side. I don't know why. I just do that. Oh, I know why. Never mind. I know why. Because I like math. I like starting from 0 over here. Okay. So we're going to draw this, the picture that I keep drawing, because I want to start with a nice fresh picture. Here's the sun, and then we have Mercury, and then we have the Earth. Okay. And I want to start them together, right? So the Earth is here, and Mercury is right here, and we see the dark part right here. It's a new Mercury. It's called an inferior conjunction. And what's the date? Well, the first time we looked at it, it was 225, right? 226, sorry, 226. So the next time Mercury comes back, is the Earth going to still be here?
No.
No, the Earth doesn't stay there.
Mm-mm.
This is actually why it's called Synodic Period, because the Earth is moving. And in fact, in 4 months, how far is the Earth going to move? How far does the
About a
Earth
quarter.
move?
A
A quarter? Are you sure it's a quarter? Not a quarter. 4 months is
No.
what fraction?
No. Yeah.
One
It's
what?
only 1/4.
Not 1/4. 3
Oh, you're
months
talking
is
about-
1/4.
Right.
1/3.
Right.
It's going to go 1/3. So I want you to divide the circle up into 3 equal pieces. You don't have to be perfect. But what is 1/3 of a full circle? How many degrees are there in a full circle?
120.
120.
360 and a full 120.
Yeah, right. So 120 degrees, 120 degrees, 120 degrees, right? Let's just draw that, okay? So when the Earth is over here, then Mercury is going to line back up again, right? Mercury is going to be lined up again. That's going to be, about 629, okay? So 4 months, and actually you guys knew this already, right? How long does the Earth take to go once around the sun?
12 months.
1 year, right? 1 year. About how many days are there in a year?
360.
About 360, right? Because we're friends. And how many degrees does the Earth go through in 1 year? 360 degrees, right? So every day is how many degrees?
10.
1 day, 1 degree.
15.
1 day, right? Every day is
Yeah.
1 degree. So in 4 months, the Earth goes 120 degrees. Are you with me?
Mhm.
Okay, all right. Now, when they take off, remember that the Earth and Mercury are lined up with each other. They are in conjunction, right? But who's going to go faster, Mercury or the Earth?
Mercury.
Mercury goes much faster, right? So they take off, but Mercury is going to go ahead, right? It's going to go much faster. And the Earth is kind of pokey and slow, right? And Mercury's like, I'm going to catch you, Earth. And Earth gets over to here, and Mercury catches them in the orbit. Are you guys with me? So they
Yeah.
started here, but Mercury is much faster. It's like not slowing down for Earth, right? And then they catch here. I don't know if you can see that. Do you guys follow that?
Yes.
Yeah.
Okay, cool. All right, so back to our worksheet.
Mhm.
How many degrees did Mercury move during the Synodic Period? So look at this. Did Mercury do 120 degrees?
Yeah.
Well, no, actually it went much faster than the Earth. It did a full lap plus 120 degrees. So the Earth went how many degrees?
480.
120.
120 degrees, right?
Right.
In 4 months.
360,
And Mercury went how many?
460. 500.
It went 360 degrees
500.
plus
400
120. How much is that?
500.
480 degrees.
480
Yeah.
degrees. Yeah?
Jeepers,
400
my math
degrees.
is off.
What's that?
I said, man, my math was off.
Yeah, a little bit. Yeah. It's okay. Don't worry. That's okay. Write it down. Okay. So let's write that down. How many degrees? 480 degrees, right? That's 480 degrees. So if it wasn't 124, if it had been 4 months, what's a month?
30.
About 30 days, right? So what did you say? 4 months is about 120 days, right? Wouldn't you say it's close to about 120 days, right? How many degrees per day did Mercury move, right? And so it went 480 degrees in about 120 days. If you do the math, how many degrees per day is that?
4.
4. Put that 4 degrees for every 1 day. Put that in, 4 degrees for every 1 day. So when we look at Mercury, we see it from the point of view of the Earth. But what if we could hover above the solar system, right? And we could watch Mercury do 1 orbit around the sun. The time it takes Mercury to go 1 orbit as relative to the stars is called the what period?
The sidereal.
The sidereal period. So the synodic period was 480 degrees, right, around the sun. But the sidereal period is going to be the time it takes, actually the time for 360 degrees around the sun. And we just figured out that it goes about 4 degrees per day. So how many days is it going to take at 4 degrees for every day? How many days will it take to get 360 degrees? And this is the answer to the question. How many days would it take? So who can do the math? 4 times blank equals 360.
$36 at 60.
Yeah, 36 divided by 4.
It's 9.
9.
90 days. Write that down, 90 days, right? Now, that is not perfect, but frankly, I'm not surprised because we did all these little things where we didn't give the exact numbers, right? The actual period, write it down. The actual period is not 90 days. It's 88 days. What do you think? Pretty good, right?
Pretty close.
Pretty darn close. And we kind of fudged a little bit, so it's okay that we didn't get the exact right answer. Now, in fact, you would need to do a couple more tries before you got a very good answer. This is not something that you can immediately see in a single period of Mercury. You need to watch it for a while. But after a while, you would get an average of 88 days as seen if you watched it from space, right? Okay, so now we get to do something fun. This is a funny little activity where we are going to actually figure out the distance to Mercury. Oops, Mercury, sorry, I put an extra C. And the sun, right? What is the distance between Mercury and the sun? Pretend you don't know. You could go look it up, of course. But what we have here is a little line, and there's the sun here and the earth here. Does anybody know the distance between the sun and the earth? Has a special name.
It's 1
AU.
AU.
It's 1 AU. Very good. That's right. So if I'm looking at the sun, and I'm watching Mercury over here somewhere, would that be Eastern or Western elongation? Which one would it be? If the sun is here and Mercury is over here.
Eastern.
That's Eastern, right? This is Eastern elongation. So what we're trying to figure out right now is a special place in east over here, east of the sun, that we're going to draw. Now, if we were at the planetarium, I would be giving you a device like this. Does anybody know what this device is called
Yes.
for measuring angles?
I have one.
Oh, that's awesome. If you have one at home, that's awesome. I don't even have one here, but I'm going to show you a little trick. If you have your astrolabe, we can use that to do what I'm about to do. Okay? So if you have this thing, you can use that. All right. Okay, if you guys are ready, I'm going to show you how this works. So we're going to actually look for a very special place, because when Mercury is at the greatest eastern elongation, then Mercury will be here, the sun is here, the earth is here. We're going to measure this angle. We're going to get this angle at GEE, greatest eastern elongation. And the reason is that it makes a beautiful little triangle. Anybody know what it's called? A triangle that has a right angle in it? Huh?
The right triangle.
A right triangle. Okay, cool. And even though this is not a math class, there's something you need to know about triangles, right? If I take a little triangle, okay, and it has a right angle, and I have an angle here, put a little line like that, and I have a different angle here, put a double line like that, okay? And I'm going to put some labels here. I'm going to call the side A, little B, little C. Erica, don't worry too much. We can always make it work. All right. You can do it afterwards if you want. Okay, now what I'm going to do is draw a big version of the triangle. And it has the right angle again. And this angle is the same as this angle here. And this angle is the same as this angle here. So what do you call it when two triangles have the same set of angles? Does anybody remember what that's called?
In Portuguese.
They're called similar triangles, right? And these are really cool because they have a neat property, right? So if this side next to the angle between the right angle and this angle is called A over here, I might call it capital A. And this one between this angle and this one, call that capital B. And the longest side, call that capital C. One of the properties of similar triangles, I don't know if you remember this or not, but if you wanted to know big B, it turns out big B divided by little b equals big A over little a, and it equals big C over little c, right? The big over the little is always equal to the same ratio. The ratios of any two sides will be equal. And it turns out you don't even have to do, you don't have to mix them up like this. If I said, what about little b over little a? What would that be equal to? And the answer is big B over big A, right? Any combination that you want, it's always going to work out like this. That's kind of neat, right?
Yeah.
It's a beautiful property. So if you can make a little triangle to represent a big triangle, and you can measure the little triangle, you can figure out what happened with the big triangle. Kind of a neat little trick, okay? Or you could use Sohcahtoa. Anybody know Sohcahtoa?
Oh God.
This is
It's
called trigonometry. We're not using that, but I'm just telling you, you could. We're not going to do trigonometry in this class, but that's basically what it comes from, trigonometry. Okay? All right, so we are now going to watch Mercury and look for the moment when it is at greatest eastern elongation, because it's going to make a right triangle. Remember I told you about this right angle here? So Mercury will make a right angle with the sun, Mercury, Earth. And here's the Earth and the sun. So we know that one, right? And then we'll be able to get this distance between the sun and Mercury, right? That's what we're looking for. What's the distance between the sun and Mercury, right? So the trick is, we have to measure this angle. What is this angle? What should it be? I don't know. We're about to find out, okay? So I'm going to use Stellarium again, and I'm going to show you a neat little trick, a very cool little trick. This is like crazy cool. Actually, it's so powerful. And I'm sharing with you, just one second. Okay, I'm sharing with you Stellarium. Okay, so you can try to do this. You can't do this with the web app, but you can do it with the regular app. Okay, so I'm going to keep the sun in the center, and I'm looking for the greatest eastern elongation. So Mercury, I guess I do need to see it, is supposed to be lined up with the sun right now. It kind of is, I guess. Okay, it's hard to tell, but I'm going to try to do this thing right here. So down here it says astronomical calculations window. Oh, what the heck is all this? Okay. And now this is going to be planetary bodies. And you'll notice that I already have something set up right here. Angular distance. Okay. Angular distance. So what I'm doing is I'm going to actually be moving time forward, and I'm going to watch the angle, and I'm going to try to get the angle to be as big as possible. Right now it's very small. In fact, if you guys watch, it's getting bigger. Okay, let's make it almost, never got to 0. Okay, well, let's go ahead and go around. Okay, you see Mercury getting further away from the sun. See the angle here, 11. I don't want the west, this is western elongation, right? I don't want western elongation. I want to do eastern. Can I keep this? I can only make one of them highlighted at a time, sorry. Okay, can you guys see the angle though? Okay, so it's western, western is getting bigger, 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 bigger. And then it's gonna switch, it's gonna start coming back. Now it's getting smaller. Smaller. Okay, small, 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 small. Okay, it's lined up again, 0 degrees, right? 0, okay. And now it's eastern elongation. So watch for this number. We want to see what that biggest number gets to be. So 15, 16, 17, 18, 19, 20, 21, 22, 22, oh, it's getting small, hang on. 22, 21, 22, 22, okay. So actually I need to do it a second time because this is not the same number that I keep getting. So I'm gonna go ahead and write down 22 degrees. And then I'm gonna do it again, make it go through an entire cycle again. The Mercury, actually, hold on, where's the sun? Here we go, sun. Watch the sun. Okay, getting smaller, crossing over to the other side, western elongation and coming back. Okay, superior conjunction, and now it's eastern elongation again, okay? And I'm watching for that number to get as big as possible. 18, 19, 20, 21, 22, 23, 24,
Nina,
25,
you want the bagel plain?
26,
Like, do you just want the bagel? Or like,
26, almost
you want
27,
it toasted?
almost 27.
Is that it?
Okay,
You
I'm
just
gonna write down
want bread?
27.
Huh?
Okay, actually 26, I think. 26, I'm gonna keep 26, okay. All right, so I saw a 22 and I saw a 26. If I do it again, let's do one more time just to see.
You don't have astronomy?
Everybody.
And we're back to east. And we're at 10, 11, 12, 13, 15, 16, 17, 18, 19, 20. Oh, no, only went to 19. 19.5. We call that 20. Let's call that 20. All right. So I'm done. I'm going to go ahead and share over here. I got 3 numbers. I got 22, 26. Actually, can I keep the 27 after all? It works out nicer. 22, 27, 20. So I got 69 degrees for 3 numbers. Divided by 3, what's the average? 23 degrees. Okay, I'm going to take 23 degrees. All right, so now I don't want you, okay, give me 1 second. Sorry, 1 second, please. I can't find my ruler, so I'm just going to use this meter stick. It's pretty big. So I'm going to, actually, you know what? I got to use your workbook. I want to show you guys something here. Okay, so on this workbook, I have the sun and I have the earth. If you have a ruler, you can follow along with me. Otherwise, just follow along with what I'm doing. I put this right on the middle of the sun. And then I want to measure the distance to the earth. Actually, I'm going to put it on 10. It's easier to see.
11 inches.
Okay.
11 centimeters.
Do you guys see it? Yeah, I'm using centimeters. Okay. So this 1 AU is a distance on my paper of 11.2 centimeters. Now, you may not get exactly that number. It's okay if you don't. Okay. So I'm going to start off with 11.2 centimeters. And then I need a protractor, but I don't have a protractor. So I'm going to show you a little trick you can do. You're going to take any piece of paper right here, and you're going to use your astrolabe to help you get a 23-degree angle. So what I'm going to do is I'm going to go and put the piece of paper, just a little piece of paper. I'm going to put it right here at the corner, right here, so that one edge is lined up with 0. All right, that's my 0. And now I'm going to try to look through this paper and see if I can find the 23-degree mark. Okay, so, oh man, I can't see through this paper. Okay, there's 20. And there's about 23 degrees, okay? And so what I'm gonna do next is I'm gonna draw a line from the corner so that it's exactly a 23-degree angle. Okay, so there's my 23-degree angle, 23 degrees, okay? And what I'm going to do next is I'm going to fold the paper right on that 23-degree mark. So I'm going to make a little mark right here. Are you guys following what I'm doing? It's a lot of extra work, but this is what we don't have the protractors, so what we got, okay? And then I don't want it to get in the way, so I'm going to show you what I'm going to do. I'm going to fold the paper over again. so that it doesn't get in the way. It's like folding a paper airplane. I might have to do it one more time. Something like that. Okay. All right. Now, this is my 23-degree angle. And I'm going to go ahead and put it right here. If you have a protractor, you don't have to do all of this. But I'm going to put the 23-degree right on the line. And then I'm going to draw a line that goes up in this direction right here. Actually, I'm just going to make a mark and then draw with a ruler. Did you guys follow what I just did?
Mm-hmm.
Mhm.
Kind of?
So long.
You got a
Yeah.
little lost? Okay.
Yeah, no, you're
Okay.
good.
So the idea is, this is supposed to be a 23-degree angle. And I use this little folded paper to measure
Yeah.
the 23-degree angle. Okay? All right. So now I'm unfolding the paper because I want to show you the next thing is Mercury is somewhere on this line, but I don't know where. But I know that the sun makes a 90-degree angle with Mercury and the sun, right? I mean, and the Earth, right? And the Earth. So what I'm going to do is take the sheet of paper and put it right on the edge of the line. And this is a 90-degree angle right here. So what I'm going to do is slide it up until the top of the paper just touches the sun right here. And this side is touching the edge of the line that I drew. And now I'm going to complete the triangle. Okay, so if you can't quite follow along, at least sketch what I've done for you is to try to draw this triangle with exactly 23 degrees right here. And the last thing to do is to measure very carefully the length of this side right here. So I'm going to measure very carefully as I can. I'm going to put my glasses on so I can see carefully. And I move this. I guess I'm going to use this. Okay. That can't be right. That can't be right. Oh, I messed up. Did I? Oh, man, I messed it up. Okay,
No,
7.
no.
Okay, 4.4. No, I didn't mess it up. It's okay. I got 4.4 centimeters. Okay, 4.4 centimeters. So you guys have some numbers. All right. So back to the story, right? The story is that if you know, let me go back to this, sorry. This is a triangle. Sorry, I just realized this is a triangle. Is this a big triangle or a little triangle? What do you think?
Little.
It's very little.
Okay.
It's on a piece of paper. But look at what it represents. It represents this enormous triangle out in space, right?
Mhm.
This is one astronomical unit. This is the distance between Mercury and the sun, right? So this little triangle has the same angle as the space triangle. So I might call this a little a, little b, and little c, right? That's what they are. So this one actually, this is not little c, this is little c. Big C is 1AU, right? This is big C, big C. Okay, so the last step, I want to find big B. What is big B? What is big B, right? The big version of B, not the 1AU. I want this distance. So big B divided by, let's do this, divided by big C equals little b over little c, like this. So big B divided by 1AU equals, and I put in the numbers, 4.4 divided by 11.2. I need a calculator at this point. We get a calculator out. Okay, 4.4 divided by 11.2. And I got B divided by 1AU equals 0.39. So how do I get B by itself?
Take away 39 from the other side.
Multiply 1 AU to.
So I'm going to multiply 1 AU on both sides, right?
Yeah.
And what's 1 times 0.39?
39.
0.39. So B is 0.39. And do you know what the actual answer is? 0.39. That's the actual answer. So we did a good job. Great job, everybody. That is the actual answer, right? So by observing Mercury and finding this 23-degree angle, we could draw the right triangle that represents the orbit of Mercury and the Earth, right? And figure out, because of the geometry, how far away is Mercury from the sun? So Mercury is here, right? This is where Mercury will be. When Mercury is at greatest eastern elongation, it's going to be right here. All right, well, that is what I was planning to do with you guys. So we finished that page and you learned a little bit about inferior and superior planets. You learned some vocabulary. What does syzygy mean again? Syzygy?
When you have planets aligned.
Planets or moons, right? Anything. But anyways, the planets, Syzygy, right? That's a cool word. Try to drop that one a bunch of times this week, okay? All right, so that's it. I am done for today. And you guys have a quiz to take based on what we just covered. You guys should be totally ready for it. Just jump right in and take it. Don't even need to worry. You have your notes in front of you and you'll do fine. You're gonna do great, actually. But if you need it, there is a second try. You get 2 tries, right? But you wanna try to get a perfect score if you can. All right, so that's it for today. And then next class, actually, you just want to make sure you finish that telescope quiz. Oh, I can look at you guys now. I'll face you guys and say goodbye. So before the next class, don't forget, you got to take the quiz on telescopes and also finish that homework on 12A and upload it. Upload a picture for me, 12A, 12B. And if you haven't done it, please do that. And does anybody have any questions? I forgot to look at the YouTube to see if anybody had questions. No, nobody's, one person is watching. Okay, so does anybody have questions?
Am I the only one watching you now? Oh, no, you
That's it. All right. Okay, so everybody say goodbye.
Bye,
Bye,
Sean.
man.
Bye, everybody. Bye. Thank you guys for coming. Nice to see you. You look like you're doing okay. Holding up. Be strong. Yes, I know. What else can we do, right? But the sun will come out tomorrow. I promise. So be strong, okay? And look at the stars tonight, okay?
I have a question.
Oh, yes, go ahead, Erica.
Is there 2 quizzes on telescopes? Because there's one that said indoor, and some of the verbiage I didn't understand it, so I got out of it. Because the other one I did okay, but there's 2.
Yeah, so one of them you started by accident, and then I gave you another try. So you should have another try to go in and do it.
Okay, and
Okay.
is that one for later?
That's due by next week. It's on the theory of telescopes. Read the introduction. And so you want to study the theory behind the telescope. Okay,
Okay.
all right. Did you disappear? You're still there? Okay, all right. See you guys later.
Bye.
Bye. Have a good night.